In this video, we're going to look at finding the GCF and the LCM of monomials. So GCF stands for greatest common factor. So we're looking for, in this case, the biggest number that will divide evenly into both 102 and 136. And we'll take care of the variable portion separately. So there's a really common way to find GCF relatively quickly, as long as the numbers aren't too big. What you do is you write down both of the numbers. So we'll write 102 and 136, and I'm sort of going to draw a bracket here to the left. So what I have to do first is just find any common factor at all. So depending on how big the numbers are and how comfortable you are with your multiplication tables and doing mental math, or using some scratch paper to doodle some math, you just find any common factor that's possible. So the worst case scenario here, well, I know that both of these numbers are even, so 2 will divide evenly into them. So what I'm going to do after I discover a common factor is I'm going to divide. So 102 divided by 2 is 51, and 136 divided by 2 is, let's see, well, 2 goes into 13 6 times with a remainder of 1, and then 2 goes into 16 8 times. So now we have 51 and 68. And I do this again. I look for another common factor if there is one. And you'll see in this example why this can be a little bit difficult. If you're just doing some mental math, you might think, well, I don't see a common factor for 51 and 68. And the reason is they have kind of an unusual common factor in 17. So 51 divided by 17 is 3. 68 divided by 17 is 4. So if possible, you would do this again, but there's no common factor between 3 and 4. So here's where we stop. So we found all of the common factors that we could. So if you want the greatest common factor, what you do is you look at all the common factors that you found and you multiply those together. So the GCF of 102 and 136 is 2 times 17, which is 34. Now, what about the variables? Once you get comfortable, you'll be able to do this in your head, but let's just analyze the variable portions. So our first monomial has x times y as the variable part, and the second monomial has x times x as the variable part. Well, in this case, the key is in the name GCF. What you do is look for any factors that are common. And if you write the factors, at least at the beginning before you have practice, you can just circle any pairs that they have in common. So there's only a single x that they have in common. If you had a big list of variables here, you could just circle all of the pairs. So in this case, there's just that single pair, which means the greatest common factor of these two monomials is 34x. So that's how you find a GCF. Now, let's do the same thing, but this time find LCMs. So we want to find the LCM of these two monomials. Just like the previous example, we're going to deal with the numbers and the variables separately. So here's what we do. We write down our two numbers, and we're going to do exactly the same thing as before, like we're finding the GCF. So I look for a common factor between 96 and 40. You could choose 2 again, but it's always a good idea to choose the biggest number possible. And let's see, perhaps we could do better than this, but I want to make sure this is at least more than one step. Perhaps you notice that 4 goes into both of those. If you see a bigger number, of course that would work as well. Well, 96 divided by 4 goes into 9 2 times with the remainder of 1, and then 4 goes into 16 4 times. 40 divided by 4 is 10. And now you look for another common factor if there is one. Well, 2 goes into both of those numbers. 24 divided by 2 is 12. 10 divided by 2 is 5. And there's no common factor between 12 and 5. So we've done the same thing as before, but how do we find the LCM? Well, this is our greatest common factor. So 4 goes into both of these numbers, 2 goes into both of these numbers, but if we're looking for multiples, I'm also going to need a 5 and a 12. So the logic here is, well, if I want to build a multiple of the number 40, I'm going to need a 4, I'm going to need a 2, and I'm going to need a 5. And if I'm also going to build a multiple of 96, well, I'm going to need a 4 and a 2 again. This is what they have in common. But I'm also going to need this 12 at the bottom. So the LCM, you multiply 4 times 2. That would be the GCF, which is 8. But you also include these other factors to get multiples. So this is easy to remember because the numbers you multiply together look like an L. So let's see, 4 times 2 is 8. 12 times 5 is 60, and then 60 times 8, if I can do some mental math, 60 times 8 is 480 because 6 times 8 is 48. So that's the numerical portion of our problem. Now let's do the variables. So in the first monomial, I don't like that this is not in alphabetical order, that bothers me, so I'm going to switch that. In the first monomial, we have an x, a y, and a y. And in the second monomial, we have 3 x's and a single y. So how can we look at the factors and figure out the LCM? So here's the idea, the logic of it, and then I'll show you a trick for remembering it. So if you want to build a multiple of this first monomial, you need all of these factors, because if you're missing one of these factors, well, you're not going to be a multiple of 96 y cubed x. You need 3 copies of y and you need an x, so you can't lose any of these, so we need all of these. Well, if you also want to be a multiple of 40x cubed y, you need 3 x's, but you already have one that we circled at the top, so I don't need this x. I do need 2 more though. So I need 3 x's if I'm going to be a multiple of 40x cubed. I have 1 here, so I need 2 more. To be a multiple of 40x cubed y, I need a y. Well, I have plenty of y's up here, so I don't need this one. So everything that I circled is the LCM. So I circled 3 x's, so the LCM has x cubed, and I circled 3 y's, so the LCM has a y cubed. Now, the logic on that's a little unusual if you're not really thinking through it carefully. Most people, there's a little trick you can remember for the LCM. You just choose the highest exponent. So if you look at the y variable, I have exponent 3, exponent 1, choose the highest, 3. For the x variable, I have exponent 1, exponent 3, choose the highest. So it's nice to be able to think through it with the factors. That's why this works the way it does. But at the end of the day, if you just want to remember the trick, well, just pick the highest exponent for the LCM. That's fine. Anyway, hope this video helped. See you next time.